Okay, so get to move away from GPUs for a little bit and actually played around with some CPU coolers. I've actually never done benchmarking and stuff with different types of coolers. So I figured, given the fact that I now have 4 months of kind of data collection experience now with really just charting out all kinds of really fun stuff, I wanted to move on to CPU coolers now so that we could kind of talk about value and how to get the right CPU cooler, because there's gonna be some really eye-opening data to show you today. Stuff you guys may have already seen, maybe you haven't. I think it's gonna be a really interesting topic. So we pitted the $50 Thermalright Phantom Spirit 120 Evo cooler against the $100 Noctua Chromax NHU12S and the $138 Dark Rock Elite from Be Quiet. And then just for shits and giggles, we threw a 360 AIO in there to see how it kind of compares to all this. So we got a lot of stuff to talk about here, including a new equation that I came up with. I'm sure it already exists, but I think it would make Steve proud. Starforge Systems offers several PCs at various price points so you can get the PC that's right for you. Horizon PCs are perfect for the everyday gamer, with affordable and fast PCs that are great for first-time PC users. While Navigator PCs are perfect for people looking to bring their gaming experience to the next level with next-gen components spec'd for true gamers. And for those looking for light-speed PCs, Voyager PCs offer the highest-end components for those looking for top-of-the-line gaming experiences, and rumor has it they're fast enough to actually escape the grasp of a black hole. Not really, but you get the idea. And for those looking for a more sleek and minimal aesthetic, Explorer PCs feature zero RGB and a classic, understated finish, perfect for gamers and non-gamers alike. To see the full list of offerings from Starforge Systems, follow the communication portal in the description below. Oh, and the logo's a hammer. They told us to say that. Okay, so it started off really as just kind of me wanting to check out how good is this $50 cooler. And then of course, comparing it to nothing but saying, here is the results and here is the price, is only half the story. You have to have something to compare it to. So that's why I kind of started building out our charts here with 2 other air coolers and then 1 AIO. And now I can start building those charts like you've seen our GPU data charts really just start growing. The methodology was kind of fun here. Might have to start over again with a different test. It's a little more consistent. We're just using OCCT with AVX2 instruction set. Got to play with my dB meter and finally mess around with some noise normalized stuff. So fortunately this room is pretty quiet. But anyway, before we talk about the testing methodology, let's talk about the coolers here and some of their new, like their features, if you will. So the Thermalright Phantom Spirit 120, it's very Noctua-esque in the way that like the fans connect. Like, so for instance, you can see here, they have the same type of hook system, if you will. So they just hook onto the heatsink itself. The fans are actually very high quality. These really remind me. Now, Phil was actually saying, hey, they look very Noctua-like with their design, but I sort of went farther back and I said, well, if anything, I feel like this design and Noctua's design are more or less based on like how the old Gentle Typhoons were way back in the day. Because this kind of a sickle scythe design of the blade is something that Gentle Typhoon was known for and made them just amazing performers when it came to overcoming static pressure through radiators or fan grills or even heat sinks like this. Very quality feeling fan. It's got 1, 2, 3, 4, 5, 6, 7, 8, 9 blades, which is kind of like the standard. So it is a SFDB bearing V2, which is a fluid dynamic bearing, is what FDB stands for. So that means, unfortunately though, it might be a little bit prone to dust and debris and stuff getting in there. That means it's actually being suspended with fluid around a sleeve, and as it turns and dirt and stuff can get in there, it might gum up over time. So that's the downside to a fluid dynamic bearing, but you're gonna start seeing these in almost all coolers these days because they're inexpensive to manufacture. Ball bearing type would be the best bearing type when it comes to longevity. And then other than that, you might find maglev bearings, which are they're basically riding on magnetism. Magnets, bitch! You know, so they're keeping the blades and the hub and the internal sleeve from actually touching anything. It's just magnetism. It's really hard to complain about any fan type or bearing type when you can easily just change out the fan later if it starts rattling or doing anything weird. It's just a standard 120 millimeter fan, nothing crazy. And yeah, I mean, they're even RGB, to be honest. They've got pretty subtle RGB lighting, just a little bit of trim on either side of the fan right in the corners. It's understated, which is nice. It's not like crazy and in your face. Now, as you can see here, it's also a dual tower cooler design. So if I get the middle fan out here, it does have 2 towers and it's got 7 copper heat pipes. Now, it's not a vapor chamber or anything like that. It's just a contact of the Now, it's not a vapor chamber or anything like that. In fact, it's not even a direct contact heat pipe. So if it was, you would actually see the heat pipes coming through the base right here, and you would see where they were like milled flat, so the heat's actually touching the copper heat pipe. It actually has to transfer through this base plate into whatever mechanism they're using to connect the heat pipe to this base, whether it's solder or it's more than likely just gonna be solder. So that adds another level of heat transfer, and anytime you have materials between the heat source and the thing that's taking away the heat, you can add inefficiency. So it'll be interesting to see how this does. None of the coolers I tested today are actually direct heat pipes, so that might be something worth checking out. In terms of dimensions, it's 157 millimeters high. So that's how much clearance you'll have in your cases. It's obviously not going to be a very small form factor friendly. It's fairly tall. I do like that the top is flat and you don't have the top of the heat pipes like sticking up like some brands do. And you have these notches that are symmetrical, so you can actually run it either way. Or if you're running on a board that maybe potentially has quad randall RAM. Anyway, it has this notch right here so that you can actually clear those DIMMs. And then when you mount the fan, you just either can make it flush if it clears your RAM, or you can actually stick it up higher like this if you need to, which obviously will extend the height of the cooler. But I was able to install it in my test bench with a 14900K running RAM that actually has taller heat sinks, and it didn't interfere. I was able to keep it flush and it didn't look bad. So moving on to the competitors here. This is the challenger. This is the Noctua NH-U12S. It's actually been considered one of like the industry standards when it comes to being a single tower cooler, not really small form factor, but has good enough cooling to be able to quote unquote not break the bank and have a giant tower like the NHD15. But unfortunately it comes in at $100 right now. It's got 5 heat pipes, same design as the bottom of the Thermalright, where it's a full heat pipe that is now contacting the base plate through some other form or mechanical connection, whether it's more than likely going to be soldered. So it's a very similar design to the Thermalright, or should I say Thermalright's very similar design to this, and has the same mechanical connection of these clips that hold the fans on. Very easy to get on and off. There's no RGB or anything on this one. Has a very standard Chromax fan, which is a more high pressure, static pressure fan that you would find from Noctua. Quality of the fan in terms of weight, actually the blades on this are even much lighter than the Thermalright fans, to be honest. But it has pretty, it's got obviously the Noctua quality when it comes to the fan. But this is the tower right here. So if we're just going about heft, you would expect at this point already that the Thermalright is going to absolutely hand the NH-U12S its ass when it comes to cooling, because this has easily twice the amount of fin density, or damn near it, and 2 extra heat pipes, 7 heat pipes versus 5. So $50, $100. Keep that in mind as we start to look at the charts here in a moment. But we needed another double cooler to compare it to. So I don't have a whole lot in stock when it comes to air cooling, if you will, because you know me, I'm a water cooling slut. But when it comes to air towers, I did have this Dark Rock Elite hanging out right now. Now this is a $138 cooler today on Amazon, nearly 3 times the cost of the Thermalright. Now when it comes to functionality and features, there's things you are getting for that cost. For instance, weight alone tells you it's beefy. It's got 1, 2, 3, 4, 5, 6, 7 heat pipes, just like the other design. They are full-size heat pipes, so they're not milled and touching the heat source directly, so they are going through another plate. The middle fan here actually just literally pops out like that. It's a little magnetic cover for the trim right there. So here's the middle fan. You've got RGB lighting up in here. You've got a small connector right here, which is designed to connect this other fan to it with a single header that then goes into your CPU header for your fans, and then a single ARGB connector for this top ring. The fans themselves don't have RGB, but the top connector does. The fans are basically built on their Silent Wings fans, so you can see they've got like the ruffles for your pleasure on the blades, which are designed to kind of cut down on some of the turbulent noise, but also give more surface area to that blade to actually catch air and give you better static pressure and air movement. But really a lot of those designs are specifically just for smoothing out the airflow so that you don't get the choppy noise, which is what Be Quiet is known for when it comes to the silence of their fans. When it comes to the mechanisms, they all hold down the same way. They all have this captive retention middle bracket that is going to attach to whatever bracketry gets mounted to your CPU socket. Obviously, all 3 of them support the most common socket types. AM3, AM4, pretty much every LGA socket when it comes to Intel, including 2066, 2011, all of those. So now that you've kind of seen what we've got here, the 4 coolers that we're testing are the 3 air coolers I just mentioned, plus an EK Waterblux Nucleus 360 AIO. That comes in at $163 today, if you can find it on Amazon, because it's fairly discontinued product for reasons that you guys already know. Let's go ahead and talk about the testing methodology here real quick. It's important that you guys understand that, because this is also like a trial run for me to see how I like the data. Does it mean anything to you guys? Is it real world enough? And then I'm not so far into this testing that I couldn't change it and start over and then just work our way down the test. So I use OCCT AVX2 instruction set. Now it's interesting by using AVX because the Intel CPUs have an AVX offset, which means in the BIOS, if it detects that it's running an AVX instruction set, simply because of the intensity that the AVX instruction set can put on the CPU, it actually downclocks the CPU. But more importantly, the CPU stays at its max rated power draw. So 253 watts on the 14900K is what we were seeing regardless of the test. The reason why I don't want to use Cinebench is because every time Cinebench restarts the run, there's a power and temperature dip for a second and then it comes back up. I wanted a very constant load. The one thing I'll probably change if I redo this test is, although the OCCT stayed very constant in terms of load, there wasn't like a lot of drop and a lot of spikes. It's set to steady and it's set to fixed. What I mean by that is you can do a variable workload on it where it can allow the CPU to ramp up and slow down, and it can find inconsistencies or unstable settings that way, because sometimes the ramp up process is where you find the instability. We're not testing RAM because we weren't checking the RAM controller or RAM stability. We were checking CPU and want CPU load, which is consistent. And because we're using a fixed, which means we are not varying which cores are being loaded up, it's just loading up all the cores available to it, P-core and E-core alike. So I wanted a nice steady type of workflow. Now, the one thing I might change with this is we might end up doing something similar to what a lot of the other guys are doing actually, which is just using Blender with a very large scene that gets rendered to make sure that it renders long enough. Now you'll notice here that it's a 10-minute run, and you'll see in our graphs that's more than long enough to get steady state on the air coolers. Air coolers reach steady state very quickly. It's not like fluid where there's a lot of thermal capacity, which takes time for that to normalize or equalize its temperature. So air coolers do it very, very quickly. For the first time, I got to use my dB meter. This room is fairly silent. So the noise floor in this room is about 34, almost said dBelsius.
It's temperature sound.
34 dBelsius.
Dude, it's so hot loud right now.
I know, the temperature's so loud. This room is about 34 dB on the sound floor, and that's when we shut everything off. All our lights and stuff, because most of these studio lights have fans in them, which actually can be picked up by the decibel meter. Now, no, it's not no sound chamber that has got a noise floor that can make you hear the electrical waves in your body functioning, making you go insane, but it's better than just sort of guessing, because it allowed me to be able to normalize the fan acoustics at 40 dB, which is kind of like the industry standard, at 1 meter measured. The AIO, we had to slow down to 65% fan speed because 3 fans push it through a radiator is a lot of turbulence, which means a lot of noise. So that's a 65% fan speed to achieve that 40 dB normalized. The Be Quiet is running 100%. The fans are so quiet, it only hit 39 dB. So I wasn't gonna overvolt the fans because I can't on a computer. So those were running 100%. The Noctua NHU12S was also at 100% because that single fan is just so quiet as well. And the Phantom 120 Evo was actually at 94%. So it's a 6% available fan speed to it than where we tested for 40 dB normalized. It's running on an MSI Z790 Carbon, and the ambient temp in this room, which is controlled, is 22 degrees Celsius. So with that said, and all the talking out of the way, I needed to explain this since it's the first time we're showing you this data for our testing methodology. No surprise, the Noctua Chromax NHU12S sucked. Okay, the 14900K, 95 Celsius on the package, average. This is average, by the way. We were peaking 100. We did have 100 spikes, and you will see that in the graph. We had 92 average temp on the P-core and 85C average temp on the E-core. Not great, especially for $100. And here's the thing, like the build quality doesn't feel like it's half the price. It feels just as quality as the Noctua. The Thermalright Phantom 120 Evo, as you can see though, 10C cooler. on the average package temp at 85 degrees. Remember, the 14900K's TJ Max, or Thermal Junction Max, is 100C. If it crosses 100C, that's what we'll start doing throttling or whatever to keep it at 100C or less. Now the CPU is rated at 100C, but you don't want to run it there all the time. You'll just be hitting all kinds of thermal headroom and power limit limits, which are going to keep you from running your max clocks. And then what's the point of having a fast CPU if you can't run the full clocks that you're advertised? 81C on the P cores, or 11 degrees difference between the Noctua and the Thermalright, and 74 on the E cores, that same 11 degree delta. Here's the fun part. The Be Quiet Dark Rock Elite at 100% fan speed, which as you know is almost 3 times the cost, is only 4 degrees better on the package, 3 degrees better on the P cores at 78 versus 81, and 3 degrees better on the E cores at 71 versus 74. Now I'm like, okay, clearly you would want to grab this guy for 50 bucks over this guy for 138, because the niceness and the extra features of like the ring and the RGB and the pop-out fan and all that, that's not worth an extra math number to me, because that's just, I would rather put that money into other components. I could pay for my SSD, to be honest, if you want to think about it that way. And then no surprise, the EK Waterblock's Nucleus 360 AIO at 65% fan speed is 9C cooler than the Be Quiet at 72 degrees, 70 degrees on the P core, and 65 on the E core. So it's 13 degrees delta though between the Thermalright and the EK Waterblock's 360 AIO on the package temperature, and 11 on P core and 9 on E core. So this thing is actually performing very, very well. But maybe you need some visualization help on understanding what that means to your pocketbook. So if we look at that same chart, only now we put the price in there. Yes, I know Celsius and dollars are not the same, but the only cooler right now that has a dollar amount that's under the Celsius figure is the Thermalright. So as you can see here, the Noctua is $100 and you get almost 100 degrees of temperature for that, which is not a good factor. We'll talk about that in a moment. The Thermalright at $50, as you can see, is a hell of a value when you look at this green chart. The Be Quiet, way the heck out there at almost double versus the temperature and the price. And then obviously at the $163 AIO, it's way out there. So you're gonna get the best temps with the AIO, obviously, but you're gonna have the worst value, if you will, because the temperature is versus the price is so skewed. And that is where I came up with this. Core package average degree Celsius distance to 100C TJ Max per dollar. You say that again. Core package average degrees in Celsius distance to 100C TJ Max per dollar. So the way to understand this, if we know our TJ Max is 100, and we have a cooler that is performing at 85 degrees Celsius package temperature at 22 degrees ambient temperature, we have 15 degrees between where we are to our TJ Max. We then take that 15 degrees and divide that by the price. So that then gives us this figure that says how much temperature to TJ Max we're being given based on the price. Now higher is better in this figure. So as you can see, the Noctua is at 0.05 degrees per dollar. That's a terrible value. That tells us we are almost at TJ Max, which you already know by looking at the other chart. The Thermalright comes in at 0.3, or a third of a degree per dollar distance to TJ Max. So in this equation, the higher that number is, the better. Now the Be Quiet comes in technically in third place right here at 0.14. And then the Nucleus, as you can see, comes in at 0.17. So obviously the Nucleus is giving us the lowest temperature, but the dollar amount we're paying for that headroom to TJ Max is much higher. I'm proud of this equation. It was fun. I'm sure someone else has already come up with this. In fact, Steve may even already, but I didn't use any sort of guidance. This is just something I came up with my own, but I love that. Core package average degree in Celsius distance to 100% TJ Max per dollar. So this is where you can see, once again, this is just almost like the inverted way of that green chart, that green bar, how it was super low. It's just now you can have an actual temperature value per dollar. And the only way to be able to equate that is distance to TJ Max, because if a cooler causes you to throttle, that's bad. So we want to be under TJ Max, and then how much did it cost us to do that? So I could get that figure to be really insane by doing like a $1,000 water loop and then having temperatures that are maybe only 10C colder than the AIO. which would put us at like 0.000005 or something stupid like that. So just to recap here, in terms of value, the Thermalright is 0.30 at the best value, getting the most degree per dollar distance to TJ Maxx. The AIO is in second at 0.17, but again, we paid more than 3 times the amount of the cooler. That's not the greatest value. That's why it's literally just barely more than half of the value of the Thermalright. Third place is the Dark Rock, again, because it's not that much cheaper than the AIO, but it was a bit warmer. And then obviously the Noctua was last place. It was absolutely terrible. What we'll do later is as this chart grows, I will then create a graph where it's like linear, right? So you can see it from best to worst. But if you look at the graph over time now, this is just trying to see what was happening over time, like were they continuing to climb? How long did it take to reach equilibrium? You can see it only took about 200 seconds for the Noctua to reach its equilibrium, but the rest hit equilibrium as early as like 120 seconds on there. But as you can see, towards the end of the chart on the Noctua, which is the pink line on the top, you can see it's fine, and then it's just becomes thermally saturated, and it is just spiking 100. Now the reason why it's spiking 100 and coming back so quickly is because it does drop about 100 megahertz on the clock speed and the voltage to keep it at the power limit and the temperature limit. So we started hitting thermal throttling towards the end of the test. Now it didn't actually really show up too much in the clock speeds or the scores when I was testing it in like Cinebench and stuff at those same temperatures, just kind of learning the methodology here. But the longer we went, the more saturated it became. Remember, this is only a 10-minute test. It probably would have gotten even worse. But as you can see right here with the purple line, the Thermalright stayed right around that 85 to 88 C. Now remember what we showed you earlier was an average, so that's an average of all of those squiggly lines. The Be Quiet, right underneath it, hovering right around 82, 83 C. And then obviously the EK water blocks is all the way down into the low to mid 70s. This was a lot of fun, but it was a bit eye-opening because it really does show you, like, we've already talked about the fact that Thermalright has kind of just shaken up the entire industry when it comes to air coolers. And I'm telling you right now, the Phantom Spirit 120, and there is a cheaper version of this. Instead of being black, it's silver. It doesn't have RGB, and it's like another $10 cheaper even, but the mechanical design of it is identical. That would make that equation of whatever shits per TJ dollar per max whatever actually even better, because we have some premiums in this cooler, if you will. But for 50 bucks, I mean, how the heck could you complain with this? It is cooling a 14900K at 253 watts. It is a 260 watt TDP cooler. The Be Quiet, for no surprise, outperforms it a little bit because it is a 280 watt TDP cooler. The Noctua is a big ass, who freaking knows, because Noctua comes up with their own TDP kind of factor. It doesn't really conform to any of the other thermal power designs or thermal design power when it comes to other coolers. So I wouldn't even be able to directly compare it because the number just doesn't make any sense, to be honest. And then the AIOs are actually well over 350 watts and 360 millimeter. So there you go. What coolers do you think we should test? I need to grow this chart, and whether I make more videos about it or not, I need the data so that when we do start testing other coolers and such, we can actually give you guys some empirical, meaningful data. So I hope you guys have enjoyed this. I hope you guys now understand you don't need to go out and look, we love Be Quiet. They're a sponsor of ours, but they themselves told us one of the things that has made their life a little bit more difficult these days is how good this brand is actually doing. And that's a good thing. That's a good thing for consumers. It means you get value, you get performance, and it means other brands have to do something to bring the same level of value to you. So that's good for the consumers. So anyways, I'm excited to see what happens in the future. I want to get some other Thermalright coolers and start testing those out. If you're running one of these, rip. Sorry, it's just not good. It's just not good. For $100, the charts speak for themselves. This guy would be fine for like a 9800X3D or a sub 200 watt cooler, but why would you still get it? Why would you not get this and still throw this on your 9800X3D or your 9700X or your 13700K? There's no reason not to whatsoever, period. Time to start changing the way we think about certain things, because we've been ingrained to believe certain brands and certain names are just quality. But someone has to come and change that mindset, and right now I am beyond impressed with Thermalright's cooler. This is the first time we took a look at it. We used it in the $1,500 build we did at Micro Center. I am gonna probably pick up 4 or 5 of these just to keep on the shelf for various builds and stuff. So, all right guys, thanks for watching. Sound off down below what your favorite air cooler is and which ones do you think we should start testing. As always, we will see you in the next one.